into 1 dx, that is equal to u, that means log x, integration v, that is integration 1 dx, minus integration of into bracket differentiation of log x, that is d by dx of log x, integration of 1 dx again into dx. This is as per the rule of integration by parts, that means u integration of v dx minus integration of du by dx integration of v dx. The solution, the simplification of this bracket, integration of this bracket with respect to x, right? So this one is equal to log x integration of 1, that is equal to x, minus integration differentiation of log x, that is equal to 1 by x, integration of 1, that is again is equal to x, and integration of this one. So by simplifying this one, I will get this one is equal to, this one is x into log x, so this one is equal to x log x minus, there is x cancel, so integration of 1 dx, so this one is equal to x log x, integration of 1, that is equal to x, plus integration constant c. So this one is equal to x log x minus 1 plus c. This is the answer of the question. So in this way we can integrate the function when there is only one function. So we can put v is equal to 1 to use the formula of integration by parts. So in the same way we can evaluate the integration of tan inverse x, sin inverse x, etc., etc. So in that case we can put v is equal to 1, right? So in this way we can solve this kind of typical examples. Let us look at one more technique of integration which is very useful and very important as per the examination, which is if the example based on this formula, that if the function f is continuous in the interval 0 to a, then integration 0 to a fx dx is equal to integration 0 to a fx dx is equal to integration 0 to a f of a minus x dx, right? So this is one technique to integration when the function is continuous in the given interval 0 to a, right? So here this method is also here, if the interval is from a to b, then this formula we can write as here, if integration a to b fx dx is equal to a to b f of a plus b minus x dx when the function is continuous in the interval a to b, right? This is very important formula for to solve the examples, okay, and this kind of examples are very important for the exam of GTU, okay. So let us look at one example of following this formula, okay. 0 to a fx dx, that is equal to 0 to a f of a minus x dx. Let us look at one example. The question is evaluate integration from 0 to pi by 2 1 upon 1 plus in root tan x dx, ઓકે. સો સૌ પ્રથમ તો આપણો જે આઈડિયા છે પહેલાં આપણે સિમ્પ્લિફાઈ કરશું, એટલે કે અહીંયા જે ફંક્શન છે tan x એને હું સાઇન અને કોસમાં કન્વર્ટ કરીશ, તો આવશે this one is equal to 1 upon 1 plus in root sin x upon in root cos x into dx. Say this integral as I. Okay, so implies I is equal to, if I take LCM root cos x, then I will get here root cos x plus root sin x, and this cos x comes here, so this one is equal to 0 to pi by 2. This is root cos x upon root cos x plus root sin x into dx. This is the value of I. Say this is equation number 1. Now this function is continuous in the interval 0 to pi by 2, so we can apply the rule that f of x is equal to f of a minus x if f is continuous in the interval 0 to a. Okay, so here a is equal to pi by 2, so I can write f of a minus x, that is equal to function of pi by 2 minus x. That means using that formula I will get this I is equal to, this one is equal to 0 to pi by 2 cos f of a minus x, that is equal to a is equal to pi by 2, so this one is cos of pi by 2 minus x, upon same way here this is cos pi by 2 minus x plus in root this is sin pi by 2 minus x into dx. Right, as we all know that cos pi by 2 minus theta is equal to sin theta, and sin pi by 2 minus theta is equal to cos theta. So I is equal to 0 to pi by 2, this is in root sin x upon in root there is sin x plus in root cos x dx. Right, say this is equation number 2. Here we have I is equal to 0 to pi by 2 root cos x upon root cos x plus root sin x dx, that is number 1, and here I is equal to 0 to pi by 2 root sin x upon root sin x plus root cos x into dx, that is 2. જો આપણે થોડું ઓબ્ઝર્વેશન કરીએ તો બંનેનો ડિનોમિનેટર સેમ છે. ઇફ we add these two, equation number 1 and equation number 2, then we will get root sin x plus root cos x upon there is root cos x plus root sin x, right, because denominator are same, so we can directly add these two equation by adding 1 and 2 by taking addition of 1 and 2. So I will get this one is equal to, so 1 plus 1, that is equal to I plus I, that is equal to from 0 to pi by 2 in root sin x plus in root cos x upon in root sin x plus in root cos x dx, because this is denominator which is same in equation 1 and equation 2. This is the numerator for equation 2, this is the numerator for equation number 1. Okay, so this is cancel out, so I will get 2I is equal to 0 to pi by 2 1 dx, and integration of 1, that is equal to x for the limit 0 to pi by 2, this one is equal to 2I, and this one is equal to, implies 2I is equal to pi by 2 minus 0, this is upper limit pi by 2 minus lower limit 0, implies 2I is equal to pi by 2, so I is equal to pi by 4, then I is our value of our integral. So in this way we can solve this kind of example, which is the special kind of example and very important example as per the exam point of view. Okay, so these are some typical examples from the integration side, especially for the integration by parts, and this is the special method for the formula that integration from 0 to a fx dx, that is equal to integration from 0 to a f of a minus x dx if f is continuous in the interval a to b. So this is the solution of this kind of example. તો આપણે આજના દિવસમાં આપણો જે ક્વેશ્ચન નંબર 4 અને ક્વેશ્ચન નંબર 5 જે 2013 જૂનમાં જે એક્ઝામ્પલ લેવાની હતી એનું જે સોલ્યુશન બાકી હતું એ આપણે ફિનિશ કરેલું, અને ત્યારબાદ આપણે જે ટિપિકલ એક્ઝામ્પલ પણ 2 પ્રકારના ટિપિકલ એક્ઝામ્પલનું પણ સોલ્યુશન કરેલું છે. સો આજના સેશન માટે આટલું જ છે. થેન્ક યુ વેરી મચ ફોર ગિવિંગ.